I'm here with Kazuo Tsubota. Kazuo, thank you for talking about this interesting topic with us today. Now, you propose the idea that the eye is not only a camera, but it's a clock. What does that mean, Kazuo?
You see, the ophthalmologist has been taking care of the eye as a camera because this is a device to see. But, we recently, not we, but the researcher group has found the eye is also working as a clock. So that means this system is an intrinsic ganglionic photoreceptor system, not giving the information to the visual cortex, but giving the information to the suprachiasmatic nucleus and giving the information to the circadian rhythm. So that determine the clock of our body.
So the ganglionic photoreceptors, are they detecting light at the same sort of wavelength that the cones are for visible light for visual processing?
Thank you for asking that. The camera, the eye as a camera can see the visible light. That means like from the 380 to 780 nanometers wavelength, from purple to the red. However, this clock system only see blue light, peaking at the 460 nanometers.
Now, do you think that, I'm going to ask you to speculate on something physiologically here, but do you think that teleologically that is the important wavelength because the mix of blue light itself goes down naturally later on in the day as the sun sets?
Yeah, somehow the human or other animals using the blue light because the sky, I think, is blue. So daytime means blue. And we are not using the other light like red or yellow as a source of the clock. So that is very interesting.
Now, even in our studio here,
yeah, we have blue light.
we have LED lights that look to me bluish. Does this exposure to blue light over the course of the day matter? I mean, this is not how we evolved.
Yeah, actually, this is good. Now it's 10 o'clock in the morning.
Yes.
So it's good to be exposed. However, if we are having this interview at night, this blue light gives us the information. Right now is a daytime. So our brain thinking, it's a daytime, so suppressing the melatonin or other sleep hormones, so disrupts our circadian rhythm.
So melatonin production is linked in with the exposure to blue light?
Yes. When there's a big volume of the blue light that suppresses the melatonin, and if we don't see the blue light, melatonin goes up, so we are going to sleep at night. But if you have a very strong blue light at night, the melatonin production is suppressed dramatically. So that is one of the reasons that the people don't sleep. You may know that the sleeping hours, averagely speaking, it was 9 hours per day 100 years ago. Now it's 7.3 hours per day.
But I've a problem, Kazuo, which is that I can't stop working when the sun goes down, or I'll never finish these videos.
Yeah, I understand. But for your health, I strongly advise not to doing a computer at all at night. But it's not a practical, I understand. So the way I advise to my people and also to myself is that I use a protective eyeglasses, blue light cut glasses in the maybe from 6 to 10 o'clock at night. Even with the protective eyeglasses after 10 o'clock night, I stop working.
Now, these are tinted glasses?
No.
I mean, the ones that you're wearing now.
This is totally transparent, you can see. But this cut 30% of blue light. And the company called Jin, in Japanese company, has developed a very interesting blue cut glass series. And this is 30% cut. and the other is a 50% cut. So when I go home, I change from 30% cut to 50% cut. Then it's much better.
And well, I mean, I can't ask you if you sleep better. I'm not going to ask you a personal question, Kazuo. But typically in ophthalmology, when we think of the questions dealing with blue light, we're thinking about things like toxicity to the retina, and in vitro studies showing that there is some, and in vivo human studies not being so clear. But this, you're talking about something different, a different role for blue light.
You're correct. That the blue light has two aspects. One is the damaging the eye, and the other is, affecting the circadian rhythm. So we have to pay attention for both of them. And our group is now working on the how the blue light damages the retina. And animal studies show the blue light is really damaging the retina. The UV light was considered to be a very major player, but actually UV light does not go through the cornea or lens. So a real player might be the visible light range, that is purple and blue light.
Yeah, interesting stuff. Kazuo, you've come up with a cute little graphic with the eye as a camera,
right,
and a clock. Kazuo, one of the rationalizations for intraocular lenses that have blue blocking chromophores is that they're really not that different from the normal blue blocking that a crystalline lens does in a patient of even younger than my youthful age.
Right. So it is a very interesting issue, which kind of lens you use, the clear lens or yellow lens. But before that discussion, we have to pay attention to cataract. Okay, we do the surgery for the cataract to treat the eye as a camera. But also, the cataract is a condition that it is not working properly as a clock. Because when the human lens is getting yellow, there's a less transparency of the blue.
So I understand what you're saying. So even during daylight hours, they're not getting the blue stimulus, and it's going to throw off their clock.
Yes. So blue light is not a bad guy. Blue light is necessarily at the daytime and not necessarily in the nighttime. So in the cataract people, or even just the old age people without cataract, even with the visual acuity of 20/20, if you get older after the age of 50, the transparency of blue light is much, much less, like 1/3 of young people. So we had a hypothesis that maybe the old people don't have a good sleep because of the lack of blue light at daytime. So we did a survey that we have found that after the cataract surgery, a lot of patients sleep well, and a lot of patients can walk faster. So the surgery of the cataract is not only the treatment of the camera, but also treatment of the clock. I'm having a life intervention instruction course at the academy, and which explained all the not only the clock problem, but also the exercise of food, all those things. So this will be the very interesting, I think, trends.
It's cool stuff. I mean, obviously, when we think of the eye, our goal is typically vision, but you've given us a new palette here. Kazuo, thank you very much.
Thank you, Joshua.
どうもありがとう。
どうもありがとう。